Good day, everybody. How are you doing? Today, we are going to talk about nuclear reactions. So I'll share my computer screen with you. So as I said, we are going to talk about nuclear reactions, salient features. Three types of rays, alpha, beta, and gamma, are produced by decay or breakdown of radioactive substance, such as uranium. Two of the three are deflected by charged metal plates. Alpha rays consist of positively charged particles called alpha particles and are therefore deflected by positively charged plate. Beta rays consist of negatively charged particles called beta particles and are therefore deflected by negatively charged plate. Gamma rays, also known as gamma radiation, is a penetrating form of electromagnetic radiation arising from the radioactive decay of atomic nuclei. Now I'm going to talk about nuclear fission and fusion reactions. Fission is the division of heavy nucleus whose mass number is greater than 200 to form smaller nuclei of intermediate mass and one or more neutrons. Okay. The significant feature of uranium-235 fission is not the enormous amount of energy released, but the fact that more neutrons are produced than are originally captured in the process. This property makes a nuclear chain reaction, which is self-sustaining sequence of nuclear fission reactions. In contrast to the nuclear fission process, nuclear fusion, the combination of small nuclei into larger ones, which is largely exempt from nuclear waste disposal problem, is called nuclear fusion reaction. Nuclear fusion reactions occurs constantly in the sun. The sun is made up of mostly hydrogen and helium. In the interior of the sun, where the temperatures reach about 15 million degrees Celsius, hydrogen undergoes a fusion reaction to produce helium. Because fusion reactions take place only at high temperature, they're often called thermonuclear reactions. Radioactivity. The rays emitted by a uranium compound is highly energetic and cannot be deflected by a magnet, and they arise spontaneously. This spontaneous emission of particles and radiation is termed radioactivity. Any element that spontaneously emits radiation is said to be radioactive. A peaceful but controversial application of nuclear fusion is the generation of electricity using heat from a controlled chain reaction in a nuclear reactor. Currently, nuclear reactors provide about 20% of the electrical energy in the United States. Except hydrogen, all nuclei contain two kinds of fundamental particles called protons and neutrons. Some nuclei are unstable, they emit particles and are electromagnetic radiation spontaneously. The name for this phenomenon is radioactivity. For example, the isotope of polonium, polonium-210, decays spontaneously to lead-206 by emitting an alpha particle. What is nuclear transmutation? Another type of radioactivity known as nuclear transmutation results from bombardment of nuclei by neutrons, protons, or other nuclei. An example of nuclear transmutation is the conversion of atmospheric nitrogen-14 to carbon-14 and hydrogen-1, which results when the nitrogen isotope captures a neutron from the sun. Radioactive decay and nuclear transmutation are nuclear reactions which differ significantly from ordinary chemical reactions. In chemical reactions, atoms are rearranged by the breaking and forming of chemical bonds. In nuclear reaction, on the other hand, elements or isotopes of same elements are converted from one to the other. In chemical reaction, there is absorption or release of relatively small amounts of energy. Nuclear reactions are accompanied by absorption or release of tremendous amounts of energy. In chemical reactions, rates are influenced by temperature, pressure, concentration, and catalyst. Rates of nuclear reactions are not affected by temperature, pressure, and catalyst. So that's a big difference between nuclear reaction and chemical reaction. So I'll stop here today. If you have any question, comment, write me a note, and I'll answer to them as soon as I can. And if you like this video, please give me a thumbs up. Please do not forget to visit tomorrow because I'm coming back with another interesting presentation on chemistry. Thanks for watching. And if you like this video, please share this with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. Thanks for watching. Have a great day. Take care. See you next time. See you actually tomorrow. Okay.